So recently, I was at the American Chemical Society meeting in Washington, D.C. And while there was a really cool presentation by a bioengineering professor from the University of Utah. It was so cool, I wanted to share it with you. So this bioengineering professor is named Dr. Russell Stewart, and he teaches in Salt Lake City. And he's been studying these little worms that are called sandcastle worms. They live in the ocean, so they're underwater. These sandcastle worms, what they do is they secrete this glue, and they gather from water, so particles floating by them in the water they grab onto. These particles might be little bits of broken seashell, they might be little particles of sand. What these sandcastle worms do is they secrete this natural glue, and they glue together these particles, and then they form this encasement where they live inside this little home or this little shell that they build. Now what's really cool about this is that they do this underwater, and when they secrete the glue doesn't wash away into the water. So these little worms, which are about an inch long, the way they do this is, you know what, rather than me explain it to you, I found a YouTube video online where Dr. Stewart himself narrates how the worms do this.
This is a sandcastle worm. It lives in the ocean close to the beach. Like a lot of invertebrate organisms in this environment, it lives in a hard mineral shell for protection. The sandcastle worm has a unique strategy for building its shell, though. Instead of secreting the entire shell, like a snail for example, it scavenges the mineral part of the shell from its environment and glues them together, as you can see the worm doing in this video. This is a very clever strategy because the worm only has to produce tiny spots of glue to construct its shell. The mineral part is entirely free. The worm in this video is in a laboratory aquarium. It is adding diamond-shaped bits of silicon we gave it onto its tube. It gathers the particles with its tentacles and examines them with its building organ. And if the worm likes the particle, it applies a couple small dabs of glue and presses it onto the end of the tube. And the glue hardens within 30 seconds. Our goal is to understand how this underwater glue works and to create a synthetic version of it for use as medical adhesives.
So why is Professor Stewart studying the way these sandcastle worms do this? Because these coacervates, which is just a fancy name for one of these little balls of this naturally occurring glue, can stick together these particles like this, while in an aqueous environment, maybe they can be used in the aqueous environment that is the human body. Now here's where it gets interesting. So, let's take, for example, broken bones. So the traditional method for healing broken bones is, if you have shattered bones, you use mechanical connectors and plates with little pins and screws and so forth. But what if there were an injectable glue that you could inject into a site where there's a broken bone, and it was able to bond wet objects? A wet object being a broken bone. So this could be really useful in the construction or reconstruction of small, delicate type bones where you don't want to be using big, plates and screws and so forth to try to put it together. Well, that is exactly what Dr. Stewart and his team have been working on. So according to Dr. Stewart, this new natural glue that he and his team have developed has already passed toxicity studies, at least in cell culture, and has proven to be non-toxic. Also, this glue that he's developed has proven to be, now get this, at least as strong as super glue and twice as strong as the natural glue that is being secreted by these sandcastle worms. And to top it all off, Professor Stewart says that so far there's no evidence of bio incompatibility. And that can be kind of important, right? Because anytime you introduce something into the human body, like let's say an artificial organ, anytime you introduce something into the human body that is not natural, you run the risk of the body rejecting it. So far, Dr. Stewart says there's been no evidence of bioincompatibility with this new glue that he's come up with. So think about this. Someday, maybe, we'll be able to heal broken bones faster, more efficiently, more effectively, because of a secret, a chemistry secret, taught to us by a little tiny sandcastle worm. Now, how cool is that?